let's get started with what is physics all about? Part 1, the beginning of everything. Now, what is physics all about? Well, let's start with the beginning of the universe. Physics, of course, starts at the very beginning. So this is starting to get turned into cosmology, too. And everything before the universe, nothing existed at all. Unless you're like believing in the Marvel Cinematic Universe and thinking that before there was nothing, there was nothing. Before the universe, there was nothing. They were wrong. Now, apparently, in Marvel thinks there's an aether, but I believe science. Now, here we are. Now, before the universe, there was nothing, and some people even think that there's a previous universe just before this one, and there's a big bounce. Or, yeah. There was no light, there was no dark, there was no time, there was no space, and it didn't exist at all. So, what came to be? And what's it all made of? So, and how did it even come to be? Nowadays, we think of that come to be thing as something called the Big Bang Theory. And to be honest, it should be called the Big Expansion Theory, but that doesn't give the same rhyme to it. Also, it's very inaccurate. There was no bang, as there was no atoms and sound. Instead, the atoms and all that stuff came as the universe started expanding stupidly fast. And scientists nowadays have some theories of how the universe will all end. Also, most people actually believe in the Big Crunch theory since it became a bang and went up, then the end will be the reverse. Personally, I like the Big Bang theory because that means the universe is ageless. It can go on and 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 on forever and forever and forever. I mean, also it is a big restart. At least that means I can survive. Somehow, if I can somehow exit the universe, then maybe at least I can survive. I'll probably be the oldest man alive. And when human civilization starts up again, I'll probably just speed things up. Make the Neanderthals and wait for a while and then slowly speed things up in the 18th century. And then probably make an early World War II and World War I stuff and probably prevent everything. Now, what is everything kind of made of? People nowadays think of it as atoms. And the first guy to think of the theory, Democritus, is all everything's made up of different things. It's just that there are different types of atoms. Also, they are indivisible. And lots of people, and then smaller and smaller and smaller. Now, lots of people just thought it was actual spheres. And that there was practically loads of empty space and all that mass was spread around. And that heavier atoms can penetrate through lighter atoms. And so what Rutherford actually expected to do, there's a scientist named Rutherford, and he just decided, just for fun, he'd shoot out some alpha particles into gold plates. And what Rutherford actually expected was all of that goes through, and at least a little curve. What actually happened is that some of them went in a straight line, and every so-and-so, some of them got reflected. And that made us rethink the whole idea of the atom. So we turned it into, instead of big spheres of dense mass around it, we end up with this, where there's this one little part in the middle that is so dense that it can reflect everything. Because protons and electrons and protons are positive and negative, and if you know basic magnets, opposites attract, and protons and electrons, and opposites and the similar ones repel. Yeah, opposites attract. Opposites attract. Opposites attract. Yeah, that's a good song. And particle accelerators basically make two protons or two electrons smash into together so they can create something new. So fast that not even repulsion can separate them apart. And this is basically why the Large Hadron Collider is here. And next we're going to talk about forces. Now, forces are awesome, and they're the reason why things move. Now, here we are. Basically, forces is what makes things move, what makes a seed able to escape, what makes three people race for the last chip of their favorite flavor, an average of 3 meters per second, while this woman is trying to get, and a shoplifter is running away at 2 meters per second because it has more mass to carry, and a police officer can move at 3.5 meters per second, so definitely the shoplifter will be caught. Wow, that is... How did he shoplift that much stuff? I will have no idea. And mass, of course, matters. In fact, force equals mass times acceleration. Distance equals the speed times time. time equals distance divided by speed, and speed equals distance divided by time. In fact, people actually think it's helpful to draw it in this little triangle so that people will definitely know which is which. Like choose one, delete that into the equals part. And mass equals acceleration times force equals acceleration times mass. So of course mass matters, but mass isn't the same thing as weight or how heavy it is. Instead, it's about how much atoms or how much stuff is in something. Also, it can have just two things can have the same amount of stuff. One of them can be heavier than the other because of how dense it is or how compact it is. And so where does this force come from? Of course it comes from energy. And energy is undestroyable. It can be used and converted like magic. Also, it isn't magic. However, it cannot be destroyed. It cannot be created nor destroyed. And if someone somehow figures out how to create energy, then we basically got ourselves the greatest idea of all time. The greatest inventor of all time. Also, that's still far from the future, even if it is possible. And then, of course, then we have the 3 laws of motion. I've already explained it to you in so many previous videos, but I'm just going to say it again. There's this guy named Isaac Newton, and he basically said the first law of motion is an object which isn't moving won't start moving unless a force actually acts upon it, and vice versa. The second law says force equals mass times acceleration. And the third law says... wrong way. And the third law basically says an action has an opposite but equal reaction. Now, Newton is all like, yay! Wait, I made it too simple. Everyday people can understand. Everyday people can become physicists. I don't want that. That'll be bad for the physics community. That will ruin my reputation. So he wrote all that in a very, very overly complicated math book called the Principia, which, of course, doesn't sell well with the Royal Society of Science because they already published a fish book that was also overly complicated, which could have been made simple, and they basically had to pay their staff with fish books, and they weren't going to do the same thing with this stupid book that could be done simply, but instead it was forced into like a big math stuff that only math people can understand. Yikes. And then we even have centrifugal force where like circles, which is what makes lassos work. And of course, that's how rockets work. The third law of motion. If somehow you're in a car and you somehow throw enough cans of beans behind you fast enough, you'll probably be able to go as fast as a rocket. Opposite and equal reaction, if you haven't realized. And the only reason why regular steel sinks because it's less dense than water. Less dense than water is regular steel. However, steel ships can float because it's more dense than water. In fact, most of the volume of steel ships is water, is empty air. So that's why it's less dense than water, and it can float up. Regular steel is like 4,000 of mass per 4,000 something per 900 kilograms per meters cubed, while water has a density of 1,000 kilograms per meter cubed. So regular steel is more dense than water, which is why it sinks. However, ships made of steel mostly have empty space of air inside it. It's more like 1.2 kilograms per meter cubed, which is way more dense. So it can float easily, which is how submarines can use to sink and float. And then there's this guy named Archimedes who ran around naked shouting Eureka just because he figured out how to figure out the volume of irregular objects. And finally, we're here at energy. Energy is an odd thing. In fact, it's kind of the most important things. In fact, it can act like a superhero too. There's electrical energy, there's sound energy, heat energy, chemical energy, kinetic energy, light energy, potential energy, electrical energy, magnetic energy, nuclear energy. It's basically the Avengers version of physics. And instead of fighting bad guys, it just helps the world, and occasionally fights bad guys like dark matter and all that stuff. And it eventually sometimes fights black guys too, like quantum level stuff. But I'm not gonna go there yet. And where do you get your energy from? Of course, every energy on the Earth actually comes from the sun. At least every energy you take in comes from the sun. And every energy that is here in the universe right now was all created in the Big Bang and cannot be destroyed or created at all. And we can literally create so much more energy. Now, like, power equals work divided by time, and work equals power times time, and time equals work divided by power. That's pretty much how everything seems to be. Force equals mass times acceleration, if you remember that too. And what's the difference between heat and temperature? Heat is basically the energy coming out. The temperature is a measurement of that energy. And there are 3 systems that people nowadays use: Celsius, Fahrenheit, and Kelvin. Celsius was invented by a guy named Celsius. Fahrenheit was invented by a guy named Fahrenheit, and Kelvin was invented by a guy named Kelvin. Also, there's no thermometer using kelvins, and the only ones that exist are the ones that physicists use. And this guy was a physicist, and he figured out what 0 kelvins is. Also, it is practically impossible to go there. Not even in space is that cold. The coolest thing in the world, which is used to cool quantum computers, absolutely no one, isn't even at 0 kelvin. It is very close, but it is not there. It's not absolute 0. And then we even have to talk about waves and stuff. Waves are an awesome bunch of things that we really have to talk about. In fact, here's all you have to know about waves is the electromagnetic spectrum and what they look like. The shorter the wave lengths is basically a shorter distance between them. This is basically the shortest frequencies, gamma rays, the ones that can kill you instantly. The longest ones are radio waves, which is the reason why Wi-Fi works and the reason why you can watch this on your phone on YouTube. Please subscribe. If I get 300 subscribers, I'll work harder. I'll promise you that. And let there be light. You can use that and with water to create rainbows because the primary colors of light is blue, red, and green. And finally, reflecting light. Whatever you hit at an angle to, it'll always hit back. If you hit a wall with light, with like a ball at 0 degrees, it'll just bounce back at you. Right at you. However, if you hit a ball to a wall at an angle of 30 degrees towards the ball, it will go to the other place 30 degrees to the relevant of the other side. So basically, it would just go ahead and go 90 degrees, 120 degrees to where you hit it. Aim. And then total internal reflection is basically what makes fiber optics work. It reflects all light, so yeah, none of it will be absorbed, and so the internet will work out fine. You can also use sound energy to do all those things. And finally, which one wins, sound versus light? Well, light cannot go through corners, but sound can. Sound wins. So can sound go through space? No! Well, yes, but very, very weak, as there are almost 0 particles in space. Well, light, no need for particles. It itself is a particle. And it's also, it's sort of in between. And what about glass? Sound is muffled through glass. Light is also kind of muffled through glass depending on the quality of the glass. Also, the glass right there, it's reflectable, so sometimes light is reflected here, so we're pretty sure both is a tie. And now that we're here, I don't even want to talk about electricity. I'll save that to the next episode. See you guys soon. Now, peace. Boo!